Want to tell me how numbers 69 and 11.3 went?
Good.
Good. Cool. I guess we can go home.
We got some numbers.
Yeah, sounds good. Yeah, I got this.
You got some numbers? You want to tell me what they were? No. Hang on. Let me refresh. We were trying to sketch log base 4 of x, right? And we were completing a table. So what did a quarter in the x give us for f?
-1.
-1?
Yeah.
-1. Why? What do you, when you think this thing?
You're looking for the exponent that gives you 1/4.
Yeah. So this thing asks, what power of 4 is x, right? So what power of 4 is a quarter? -1. What power of 4 is 1? 0. You guys all with that? All right. Somebody want to tell me about 4? What power of 4 is 4? 1.
2.
Can somebody read this to me as a thought?
Wait a minute.
Log base 4 of 16.
As a thought.
Oh.
Somebody read this last one as a thought for me.
What power of 4 is 16?
What power of 4 is 16? And the answer is 2. So we could graph this, right? We just need to sketch those points, yeah? Okay,
I
so
like how you brought up that.
I know. Relax. We're going to do that part the other way next. So where does a quarter 1 end up on here? What am I looking to do?
Is that the y-axis?
The x.
Are we not flipping it yet?
Yeah, so I'm not flipping anything. I'm just
Okay, so
doing this. Like they said, right? They said complete the table and then sketch. So I'm just following their directions. I completed the table. Now what do I do with that?
The point?
would you go over a fourth and then mark a quarter?
Okay, so I go over a quarter, then down 1.
Yeah.
Okay, so
That's just weird.
yeah, that feels a little funny, right?
Yeah.
So I go maybe put 4 things on there, I guess. I want to go over a quarter and down 1. That feels really weird, right? Okay, how about the next one?
Over 1. Stay 0.
1, 0 is over 1, up 0.
Yeah.
Right here. How about 4, 1? Where's that go? Over 4 and up 1. Okay, and uh-oh. Over 16.
We'll let you do that.
Crap. Someplace over here.
Is that like an exponential growth starting below 0 or something?
Yeah, so what's going on here? Should be over there someplace, right?
Yeah.
Kind of a long ways and not very high.
Yeah.
So connecting those dots, it's going to look like this.
Oh.
And maybe you're thinking exponential growth, maybe?
Spin it.
Well,
Yeah.
Rotate it a
It
little
wouldn't be
bit.
exponential if it's negative. Because you can't.
Yeah, so this is where you really maybe would be better off doing the plexiglass trick than this thing. Right? This thing yields some kind of confusion in my head. But I do know how to draw the thing that this goes with, right? Log base 4 of x goes with, what's the inverse function for log base 4 of x?
Wait, what?
F inverse.
F inverse, yeah.
Yeah, so F inverse for this thing is what?
You just move all the points.
Yeah, but I know what that rule is called.
Oh.
Yeah, it's called F inverse, but I actually know what it is here. What's the inverse of a log? Yeah, an exponential with the same base. So the inverse for this is 4 to the x. Okay, see that? That's why we did this stuff. Right? So now if I know how to graph 4 to the x, which I do, right? This is a lot easier to graph because this is nice geometric growth, right? So I go, okay, I just want to graph 4 to the x now, right? And then I'll flip it over. So I go,
You just flip all those.
yeah, I really could just flip all those, right? You guys see that?
Yeah.
In fact,
Okay.
some of you I think I saw doing that. Yes? Swap the x's and y's because they seem to make more sense that way. That's really because you kind of think geometric growth. So if we switch them, we get 0, 1, and 1,
1, 4.
4, and 2, 16, and minus 1, a quarter, and if we did minus 2, we'd get a 16, right? A quarter is high. So we get some picture that looks like this, right?
So when you do that, it flips like the f of x and the x around.
Uh-huh, yeah. So the reason for that is that our rule f goes this way, right?
That was my problem. Is I did that for the x, but I didn't flip it when I wrote it down.
Yeah, so the inverse function goes this way, right? So of course it takes in the outputs from the regular function and gives out the inputs from the regular function. You guys see that? So if I want the graph for log base 4, what do I do with my piece of plexiglass?
Flip it up.
Flip it along the g.
Yeah, along this one?
Whatever letter you put on it.
Yeah, so I need to exchange the y's and x's, right?
Yeah.
And that takes this form. And then I have that same picture, right?
Yeah.
Check, good. So if you get nothing else from this, what should you remember? Okay. The thing that's crucial here, the crucial thing out of 11.3 and actually out of chapter 11, let's just call this the chapter 11 crucial thing. Right, is this, if I've got log base b of y is x, that's the same information as b to the x is y. You see that? There's an exponential form, right? That's a function going forward, right? That's b to this stuff. And there's a log form, that's a function coming back. And that's log base b of stuff. Okay, see that? Cool. This is the crucial thing in chapter 11. If you take nothing else, take this. If you take one other thing, it would be really cool if you had that picture for the plexiglass in your head. Right? That's the way to transition from a graph of a function to the graph of its inverse.
So if we ever end up with ones that go down like that, just flip it.
Yeah, so if you want to know what the graph of the inverse of a logarithm looks like, right? We'd graph the log like we did over here, and then we'd flip it over the line y equals x. Bam. There's a picture for what the inverse of a log looks like. You guys cool with that? Okay. Other questions on this?
I got it, no problem.
Oh my god, my brain.